Hello everybody, heartfelt welcome to all my fellow engineers. My name is Mihir Patel and today we are going to discuss compressors and their design in the chemical process industry part 1. Now again I have broken it into two parts because of the nature of the topic. So I will start with my introduction. Now I am a chemical engineer with a master's degree from USA. Also I am a PMP as well as a TUE Sword certified functional safety professional. I have more than 35 years experience in the chemical process industry and I have the good fortune of tutoring and mentoring many process engineers. With God's grace, I am also the author of Me's Handbook of Chemical Process Engineering and I have worked in many premium consultancies firms in my career. Now as you can see, the webinar will have two parts. So part 1 is today we are going to have and we will be discussing introduction, compressor types, usage selection, codes and standards, centrifugal, axial compressor, SF compressor, rotary compressors. And part 2 will be separate webinar which will cover the details as indicated here, including data sheets, central out pressures, then we will have material construction, procurement strategy, all this we will cover there. And inside each topic we'll have actual examples also. Now starting with the introduction. So back to basics. The participating engineer should be familiar with need for transporting gases in chemical process industry, the definition of a compressor, and process gas properties like viscosity, density. Now the learning module, learning objectives. So here we see the learning objectives of this webinar on compressors is as far as possible the complete background for a process engineer on compressors so that he can be capable of doing process design. Introduction to compressors. Now, compression of gases and vapors is an important operation in chemical and petrochemical plants. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Compressors are closely related to pumps. Both increase the pressure on a fluid and both can transport the fluid through a pipe. As gases are compressible, the compressor also reduces the volume of a gas. On the right you can see a large compressor. Now compressor types, uses and selection. Now compression methods. So here we look at the compression methods. You have isothermal, adiabatic, which is also called isentropic, and polytropic. So this is the isothermal. In actual nature, isothermal compression is very difficult. Then you have isentropic, where exponential is k, and you have polytropic, where actual exponent is n for polytropic compressors. So this is pressure versus volume curve. Now isothermal compression. In this process, temperature is maintained constant. Pressure and volume is altered, that is, P increases, then V decreases and vice versa. Boyle's law is applied, which is PV is equal to constant. This process is theoretical only, that is, isothermal process is not possible in reality. In actual world it is theoretical only. Isothermal calculation model has the advantage of supplying the minimum theoretical power requirement, assuming the heat of compression is fully removed by internal cooling. Now, adiabatic isentropic compression. In this process, no transfer of heat from surrounding, that is, heat due to friction takes place. Only heat of compression is added to gas. In this process, the energy of gas is increased by an amount equal to work done on the gas. So pressure, volume and temperature all change. None of them remains constant. Entropy of the gas remains constant. This process is a reversible process. Adiabatic calculations are widely used for reciprocating and rotary compressors. Now, polytropic compression. In this process, transfer of heat from surrounding takes place. In this process, the energy of gas is increased by amount equal to work done on gas and heat transfer from surrounding, that is heat due to friction. Pressure, volume and temperature all change. None of them remains constant. Polytropic calculations are used for centrifugal compressors. Now, overall compressor types, as can be seen. So here in the chart we see the overall compressor types. To arrive at the design of a compressor which will fit the requirements of the particular service, the process engineer is to review the required flow rate and pressure differential carefully, and for all borderline cases should consult a rotating equipment specialist engineer also. So here one can see on the left you have positive displacement compressors where you have reciprocating and rotary. Under reciprocating you have single acting, double acting and diaphragm type, which is a very specialized type of compressor used for very high pressure services. For example, hydrogen filling stations where you need very high pressures of 750 bars, 350 bars. Diaphragm compressors prevent any contamination from oil in the gas. Then you have rotary compressors. You have lobe compressor, screw compressor vane, liquid ring, scroll. And then for the dynamic, you have centrifugal and axial compressors. Now again, this chart also shows the compressor types. Now here we have shown the jet and thermal type of compressor. This is nothing but an ejector. So ejectors basically we have covered separately in the vacuum webinar, vacuum systems webinar, and will not be covering ejectors in this webinar. However, ejector is a type of compressor also. Brief comparison between centrifugal and PD compressors. So here you see the parameter, the centrifugal compressor and positive displacement compressor. So for maximum discharge pressure in centrifugal compressors is set by the compressor surge or by the system MAWP. In PD compressors, it is set by system mechanical limit, MAWP or temperature. Then pressure rise per stage is set by the stage aerodynamic performance in a centrifugal compressor, and in a PD compressor set by stage discharge temperature limit. This discharge temperature limit in a PD compressor is because of the oil that it uses. So you don't want any degradation of the oil. So that is why the temperatures are limited in a positive displacement compressor. Then lubricated or non-lubricated. In centrifugal compressor only non-lubricated possible. In PD compressor both are available. Then the reliability point of view I have just listed here. Centrifugal compressors are very reliable, as can be seen. Recip compressor reliability is not that high. Okay? And the oil injected screw and oil free screw are also quite reliable. A brief comparison between various compressor types we continue. So salient points I have listed here. So for recip compressors, they have lower reliability, are available in smaller capacities, can have very high discharge pressures, need proper supported piping due to the high pulsations. This is a very important point. Pulsations in a recip compressor. The foundations also are quite strong because of this reason. Foundations are required to be strong, as I mentioned. Centrifugal compressors are constant head machines, can have very high capacities, have surge limitation at turn down, and have very high reliability and low maintenance. Screw compressors. Wet oil injected screw compressor has high efficiency and high pressure ratios. However, the disadvantage is that you will have oil carryover with the gas, and you need to be careful that the oil doesn't cause nuisance value downstream. Dry screw can tolerate polymerizable and dirty gases also. In fact, if you have polymerizable gas, the clearances between the two screws decreases, and you get better efficiency also. And then high noise level is possible in screw compressors.